I don't remember. How do I introduce this? I don't remember what we called it.
I don't remember the name either.
Okay. Hello and welcome back to Science Talk. We're here for another episode in my humble home. We have been renovating. That's the word. We did a lot of work here. We got a fireplace. There's a fish tank there too. Sorry for the glare. Everything's looking nice. And today on the show, we have a very special guest near and dear to my heart, my own father. Come on. Oh, come on. It's an honor.
Great to see you again.
Good to see you.
Good to see you.
Thank you for coming over.
It was quite a long trip.
It was. The other room was really far away. Welcome to the show, Mr. Dad. How you doing?
I'm doing great.
Good. Oh, I just do want to clarify one thing. Miss Ray, if you're watching this, Jamal is producing right now. He is behind the camera. Come, step into frame. Show the receipts. He doesn't know this yet, but he'll also be doing the visuals, so... Shout out to the Photoshop job. So, Dad, you are... Tell me a little bit about yourself. What's your job?
My job.
Why am I interviewing you today?
Well, my job title is engineering manager. I work at a small design and manufacturing company where we design products for RF coaxial and mainly mil-aero and semiconductor equipment type stuff. So I design like electromechanical products, I guess you could say, connectors and cable assemblies.
Okay.
Well, the fancy word called interconnects.
Interconnects.
Yes.
Ooh. Winchester Interconnect?
Winchester Interconnect.
Dare I say?
I should plug.
Their logo is beautiful. We get a lot of their merch. They send a lot of free stuff here. I'd like to thank you. Thank you, Winchester Interconnect. But we'll get more into that later. We're going to start, usually we start at the beginning. So the beginning of the show here, we're just going to start with questions. Going to ask a few questions as we've been doing before and then move into some segments later. But as we've started before, we're going to start with education, kind of bring it back a little bit. So kind of what got you introduced into engineering when you were in high school and like why did you go to college and where did you go to college?
I guess I was always interested in math and science. So at that point, engineering seemed like a good opportunity for me. I have an older brother who was in civil engineering.
Oh.
It'd be great to interview him.
Oh, yeah.
So hearing him talking about what he was doing made me a little bit interested in what I was trying to do. Though I had a little different take. I was more interested in mechanical engineering, how things went together, how they moved, and that type of stuff.
Mm-hmm. Oh, okay. Interesting. And you went to Rensselaer, as seen by the mug?
I did. I went to Rensselaer. I wanted to go a little further away from home, but not too far.
Where was home?
Hopkinton, Massachusetts.
Not a Mainer.
I know. I'm a non-Mainer, sorry. So Rensselaer is about 4,000 students, undergraduate. It seemed like a good size for me. They had a lot of opportunities there. Very well-known school, but a lot of very good faculty. And
Really what drew you in was their mascot.
yeah, the engineer, what a great nickname, and the bumblebee. For some reason. Yeah, I don't know why, but for some reason there's a bumblebee around the hockey rink.
I love that there's not just like one school named the Engineers. There's a lot of schools with the mascot of the Engineers.
That's because engineers usually not that creative when it comes to names. You know,
I don't know.
there's no sales, there's no marketing there.
Yeah.
That's what it is. So while I was there, I started going through, and as I was taking mechanical engineering courses, I started to get a little bit more interested in the manufacturing side of it. And I actually took an internship for 7 months at a manufacturing place as a manufacturing engineer, manufacturing engineering intern. So I took more, not a minor, but more of I took a lot of manufacturing classes while I was there also. So it kind of prepped me both for the design of products as well as how you make them type of thing, which is what kind of intrigued me.
Interesting. Okay. So yeah, you went through college and you were doing that and you graduated in a nice 4 years. Got your degree. What's the official thing on your degree?
Bachelor of Science in Mechanical Engineering.
Mechanical engineering. Okay. Good to know. That one's going in the title. I think mechanical pretty popular. So after college you graduate with your mechanicals, your bachelor, and where'd you go?
Well, I worked for one company for sheet metal manufacturer as a manufacturing engineer for a year, but then I spent the next 10 years working for a larger company designing interconnects and cable assemblies as a manufacturing engineer. And while I was there, I also went back to school and got my Master's of Science in Manufacturing Engineering at Boston University.
How was that experience?
It was actually really good because it was it wasn't the same traditional classroom experience. It was all people who were currently working in the industry, and at the same time taking the classes. So we had a lot of great discussions and during class and even afterwards about what different things were going on at the different companies, because they were all totally different. Things that we could learn from them. It was very engaging and a great learning opportunity.
Mm-hmm. So, kind of wrapping up your whole college experience, how I know a lot of people talk about the difficulty of engineering and the math behind it and everything. How did you find college in terms of difficulty, and what were some difficulties of college?
Well, I was going from a very small high school to Rensselaer, which it was a real challenge when I went there, because as I first went there, it was like there's an awful lot of smart kids there, and the classes were extremely challenging. I really enjoyed it more when I got to the second half, say my junior and senior year, where I had the chance to choose a lot of different classes myself. Because originally you start off, you get a lot of your physics, for mechanical engineering, and calculus, a couple of years of that, differential equations, all those great things. But when you get further on, you can actually start choosing your classes and get more of like a concentration of what you're really interested in.
Yeah.
As well as things such as engineering lab, where we learned a lot of things like design of experiments, how to use statistics when doing some type of different engineering analysis, and really gives you the thought process of how to think things through in a logical way to try to reach the best design or the best process that you're trying to come up with.
Yeah. If you were to single out one class as being the most difficult, which one would you pick?
Probably thermodynamics. I had to take thermodynamics 1 and 2.
What's going on there? What is thermodynamics?
That's why I wasn't very good at it. It has to do, not just flow of air or liquids and stuff like that. You're dealing with heat transfer within that, and a whole bunch of stuff that I really wasn't all that interested in. I guess if you were doing like the HVAC side of mechanical engineering, where you're heating and ventilation, where you could be working for a large company like Carrier or something like that, it'd be great for you, but it really wasn't my thing. I was interested more maybe the mechanics part of it, which would be things associated with strain, stress, and things like that, as well as movement and stuff like that.
Yeah. Okay. Cool. Did you have a favorite class? Most fun?
Probably I took a. That's a really good question. I don't really have one.
I didn't ask you that one in advance. I usually try to give them the questions in advance. I
don't really have one class that I found the most interesting. I did have to take one engineering. I can't remember what they call it. It was like a full engineering project where I got to work with 2 other students, and not only did we have to come up with a design and go by the calculations behind how it worked, it was something that's supposed to be usable for someone in the community. In this case, it was a chair that would operate and move back and forth to help some people with some disabilities. And we actually came up with like a full-scale mock-up using different stepper motors to get some movement on it. We put in a lot of hours, a couple all-nighters to try to get done. But it was really a fun thing, because everybody on the team really pulled together and did their part, and it was a great learning experience.
Never heard this story before.
Plus, at the end of it, we then got to present it in front of the professors. Not just my current professor, but some of the other ones in the mechanical engineering department. And it was really a great experience for me to start to get used to presenting our own ideas and fielding questions and talking about it.
Oh, that's awesome. Wow. Like I said, I hadn't heard that one before. That's a new one for me.
I'm full of surprise.
I know, you got a new story every time. Well, that's not true, but... So, after you got out of college, I know you talked about you went and you got your master's, but you got that through the company you were working at. So how was getting that first job?
Well, I actually went into the workforce at a pretty bad time. As I like to joke about, it was when peace broke out. When
bad for business.
It was the Soviet Union, collapsed, and there weren't as many jobs, especially in the military area.
They don't need any more missiles? Are you sure?
They didn't. Originally I was supposed to work I had a real good job opportunity in a company that made Tomahawk cruise missiles, and suddenly there was a much less of a demand for those at that time. So that job filtered away. So it wasn't great. So that's why I eventually took a job working for a sheet metal company where I did more manufacturing than engineering. There wasn't a lot of it. And then sent out a lot of resumes back then, where it was back the old paper resume
resumes?
time. Yeah. So it was a little bit more difficult. You had to do a lot of applications. It helps when you know people to try to get through. I eventually found a job in Amesbury, Massachusetts, where I worked for 9-10 years.
Yeah. Was that true, or was that someone else?
No, that was it was originally Adams Russell, which got bought by Macom, which got bought by AMP, which got bought by Tyco Electronics.
Mouthful.
Yeah.
Anyways, they paid for your nice master's degree from Boston University. I've kind of heard a little bit about this myself. I kind of found it interesting. So you're working while you're getting your master's degree.
That's right.
How does your schedule work for that? Where are you doing it? Because you're not on campus for this, right?
We were actually. And this is a specific case where the company had to agree to let us go every other Friday. We got to go to this campus, and there was a remote campus of Boston University. Their Tingsboro campus, where you could go there, and they had some classrooms and different things like that. So we actually went there, went to class on Friday, stayed overnight at a nearby hotel, and then came back the next day, and it was another full day of classes. So we did that every other week, and then it was, between that, it was a lot of homework and a lot of work. Thankfully, back then, I didn't have my son was not born yet, so I had a lot of extra time.
No problem.
Yeah, it was. And a very understanding wife at that point. So it took a lot of work. Took about
No
18.
dog either.
No. So it took about 18 months to complete the program.
Mm-hmm. Yeah. And that was in manufacturing?
Manufacturing engineering, yeah.
Okay. And so you eventually switched companies, right?
I did. After working for a manufacturing engineer at the company I was at, I switched to a new company. At that time it was True Corporation, and I also switched positions. At that point I took a job as a design engineer. But it was in a company that has fairly small, that had its own machine shop, own assembly area. So the manufacturing engineering part I was familiar with, as well as the type of products I was designing, I was very familiar with where I'd worked before. So it was a good transition. It was a good time to start being able to stretch myself a little bit further, apply what I had learned on the previous job, and then expand that into a new position.
Okay, that's good. Nice. So this is still you're still working at the same place essentially, right?
I am. I've been there for like 21 years now.
Mm-hmm. They got bought out, but it's still the same company.
Still the same. Better logo, but different.
Better logo?
Yes.
Really? I kind of liked True.
Yeah.
And I do remember my favorite thing was when I'd call Dad and the ringtone would be, or like you'd pick it up and you'd be like, True Corporations, Andy Mosley speaking. So the Winchester Interconnect it doesn't sound as good. True Corporation sounds better. Anyways, I digress. Aside from my favorites. So you're still at the same place. Can you just walk me through a day at work?
Sure. Every day for me can be different because we typically design per a customer's order. There can be a day that's, there are days that are very busy in one thing, very busy in the other. Because I could be at a point where I'm talking to a customer about an application that they have, trying to find basically an interconnect solution. It would be a coaxial connector, a cable assembly like a transmission line, as well as the mating receptacle would go on the other side. Trying to find something that fits their requirements, whether it be an environmental, whether it be a mechanical portion of it, whether it be the electrical part of it that they have to be concerned about. So I have to kind of take all that account, work with the salespeople, and try to come up with a solution. And that can actually take months to go through all that. So then I actually use a CAD system. We use SolidWorks to do our modeling, our 3D modeling and design. We have a separate program we use for electrical simulation, ANSYS, HFSS, which is a simulation of the microwaves through the cable assemblies.
Like microwaves?
No, not really. I mean, you're talking different frequencies that you're operating at.
Of course.
So we'd go through that, and then eventually design it. There's a fun part of it. You have to create product drawings and piece part drawings because we have to be able to make it.
Did you used to have to hand draw them?
I never hand drew them. We actually had people that did hand draw them.
They've probably been in the business for a bit.
They had been in the business for quite a while, and they were very good at it.
Ah.
And then those people actually moved on to, they call it drafting, and those people started to move on to using CAD systems, same type of thing. But then after that, for the day, I have to load the ERP system, which is basically taking it all into our computer system so that they can do production planning, scheduling, because you have to be able to make it. You have to have resources of equipment and people and things like that to get the schedule out. In addition to that, there is also the maintenance of existing products that we have. Whether it be a current issue on the production floor where they may have an issue with a component or an assembly or do some type of troubleshooting for something that may have a type of defect. Also have to deal with if there's any type of return. If a customer has an issue, we do some troubleshooting of the product that came back and determine what the root cause is and assign, whether it could be a customer issue, maybe they're misusing it, or maybe there was a manufacturing defect in that product.
Yeah.
So,
Does that happen very often?
no, not really.
Not many defects.
No, the majority of the defects that we have are typically in-house. We don't ship products with defects for the most part.
Yeah. Gotta keep the esteem up.
That's right. Sometimes it's an issue where a customer is using a product that it's not really designed for because there wasn't enough interaction up front to get what they need. Sometimes they're just pushing the envelope on things. Putting more, in our case, they're putting more power through it. Or maybe they're using it in an environment where it's getting too hot or that type of thing.
So who are these? What types of mythical customers are these people? What are they trying to build? What are they using your parts in?
Okay, they're really, for us, you could in essence break them out into two main groups. We have the traditional mil-aero defense type products. Radar systems that you have on aircraft, ships, ground-based things, they all have to be able to go from the antenna back to their particular device in the box that they have. And there are transmission lines that go in between, and there are interconnects on each side of it. So those are some of the products that we sell, commercial as well as military aviation, or also there are space applications. Some products go into satellites and things like that. The other side, which is the group that I'm in, the largest side of the business, is the semiconductor equipment manufacturers. These are the folks that make the equipment that the folks like Intel use to make the chips for products. They actually use a lot of RF energy to excite the plasma over the actual wafer, what they're doing. So they need power delivery. Now you're getting past what I understand.
Okay.
So they have typically when you look at the wafers, there's one of two things. It's either etch or deposition, meaning they have it and they're trying to remove material or they're trying to deposit on small little layers. So when you see a computer chip and you see everything on it, all the copper layers and everything, and that's all typically either added on or taken off. And they have a way of etching or removing the material. Each company has like their own secret sauce, what they do.
Ooh, yes. Krabby Patty formula.
Right. So those are typically power delivery systems that we're doing. They have what they call a generator, where they're power, and we could be talking like 10 kilowatts, 20 kilowatts, that type of thing. And you transmit that power to another side, and it could be in like a clean room environment. And on that side there would be some mating, connectors that would go through that.
Okay. It's a little complicated. You
Sorry.
lost me a little bit.
I'm sorry.
No, that one's on me.
But they're two entirely different applications.
Different types of people.
Right, different types of people. The mil-aero are really concerned about environmental conditions. It could be out in the severe weather, snow, ice. It could be at an altitude. It could be on you have to deal with salt spray if it's a naval application. Right, and even things like if it's on an airplane that lands on a carrier, it has to be able to handle it when the carrier launch as well when it lands. There's sudden shock and vibration it has to withstand.
Wow, a lot of requirements.
Yeah, there are quite a few, and that's part of the job is going through the requirements and coming up with a product.
Do you get a list of the requirements, or do you have to figure them out based on?
We typically will get a full-up specification that will contain it, and typically with those programs, there's already how the Department of Defense is. There's a whole series of requirements that are standard that they can pull through, and they can say these are the type of conditions that.
I'm gonna be honest, I haven't talked to the Department of Defense very much, so I don't really know how they are. But I'll take your word for it.
And each of the branch have their own type of requirements, and then there are a few projects where they don't tell us because they can't tell us. And they say it's kind of like this, and we just kind of have to work through the range and make sure it works through a broad range of things.
Yeah, big government trying to keep you down.
Well, the man
with his iron fist.
Yeah, as long as he pays his bills, that's okay.
Yeah, that's fair. So yeah, those are your clients. Well, what's your favorite part and your least favorite part of the job? Pick whatever one you want to go first. Whatever's easier.
Well, we can go to the favorite part, which is some of the stuff I already talked about, where I actually get to interact directly with a customer. Because where I work, I can deal all the way from coming up with the original concepts, designing the product, seeing it made, because we have a full machine shop and an assembly area, and then test the product when it's made before it even goes to the customer. So it's seeing it all the way from design concept all the way to build and shipment. The least favorite part of my job is paperwork. There's a lot of paperwork, and it can be paper literally, or it could be paper, a file on a screen that the operators are using.
Yeah.
It's necessary. They need to know how to make it, how to build it, as well as process steps for things that they need. So the amount of paper that we have to do could be markers on a cable that require, we had one job where it required 20 different unique markers on it. Yeah. So we had to create drawings for each one.
Do you usually do the paperwork before or after you do the fun part?
Usually it's kind of in the middle.
In the middle, okay.
Right.
Yeah. Well, I was going to ask this earlier. So do you test? You have all these requirements, but do you run tests at the facility?
We do. We do some basic production testing where we're doing, most of it's electrical testing, where you start with basic continuity, voltage, and then there's a series of what we call S-parameter testing that we have to do. We have vector network analyzers we use for testing the products. I probably don't want to go into too much detail. No, the products, actually our products range all the way from extremely tiny. We have these products we're doing right now that we have to look under a microscope to see it.
Yeah.
All the way up to products that are about this big in diameter. Oh, so it ranges significantly. And the cables can vary from being 0.04 thousandths of an inch, which is really small, all the way up to 2 inches in diameter. So it goes all over the place.
What are the things you make? Cable assemblies, connectors,
adapters. Yeah.
What do they do? What's a cable assembly do usually?
It connects two things.
What's a connector do?
So think of it this way. You have a box somewhere. Someone has a box.
Someone's got a box. Okay.
And it could be, let's say it's on an antenna, right? Yeah. And they need to have it over here. They've got their system where they'll take everything from the antenna and they'll transmit it to, say a screen. It could be like the FAA where they're trying to look at, radar and they're trying to see where everything is. So you need to get the signal from here to there.
Yeah.
So on the box, there's going to be like an output, and you call it a connector. Think of it like a hose that you have on your faucet. You have an output, then you have a hose that runs in between the two. So there's a certain connection that goes between each one. In this case, they have to work both mechanically and electrically. So, and they're uniquely defined. So you have to have that type of connector to fit this type of connector.
Yeah.
So then you will have typically what we do are flexible transmission lines. So it would run all the way through over to the other box where it's the same type of thing. You have another connector, and it has a mating connector on that box. And usually on the back side of the connector, there's typically because we deal with coaxial connectors, there'll be, let's say, like a pin that they may solder a wire to. And then there's a grounding part, which is the outer part, which could be like a flange or something that mates onto it. And then the cables that we select, usually what we're trying to do is you're not trying to lose as much signal going back and forth. So based upon the materials you can select, you can have something that it would be what they refer as less lossy material in it, so that you can get more of the signal going from one end to another.
Okay. That makes sense, actually. Yeah,
right.
I've never had it broken down.
No, but usually when we do it, there's a series of trade-offs that we have because you can't have one thing.
Yeah.
Typically the ideal situation would be like a rigid line that runs through, but it doesn't bend. It's hard to move. You can't really handle it. The more flexible you make things, then it starts to have contact issues running through it. So everything that we typically do is a trade-off that you go back and through.
Scale.
Yeah.
Just gotta make some sacrifices.
You do, yeah.
I do have one more question before we move into our segment here. I didn't ask you this one in advance, but do you have any advice for any aspiring engineers into getting into the field, whether that's school, whether they're in high school and they need, I don't know, anything?
Well, one thing to do is if you have anybody or anyone that you can find that you either can do job shadowing for a day or even just talking to them. And then when you get the experience, when you do go to college, whether it be an internship, whether it be a research opportunity, whether you work directly with a professor, what it will help you do is to help decide exactly what type of engineering, or even within the specific engineering, what type of field you want to go into. Because there's nothing worse than when you get near the end, you're like, I'm not really interested in doing that. You can kind of get through that.
It's an expensive mistake.
It can be a very expensive mistake, and it can affect your career going forward. But also what it can do is sometimes it just rules out things you don't like.
Yeah,
and there's
not bad.
There's nothing, actually that is very productive. Yeah. But other times it'll kind of give you an avenue that you may say, hey, I'm kind of interested in that, as well as it kind of goes with some of the skill sets that I might have.
Yeah, it's kind of a accumulating stuff as you go. That makes sense. Okay, it's been great.
So it can really help if you do things in school like robotics lab. You can see if you like a math, if you do math team. They're all different types of things that you can try to get into. Even if you have things at your school like a science fair, you can try doing something associated with a specific field and see if it interests you. You know, see if you enjoy it.
Yeah, and that's the beauty. I did math team. I realized, no, I'm good.
There you go.
That's the beauty of it. It's been great asking you questions, but we're gonna move on to our little segment here. We got a segment that I'll admit it's stolen 100%. This first segment, Are You Smarter Than a 12th Grader? Today we're gonna be bringing in our resident 12th grader, Jamal. Jamal, can you please bring over the boards and the markers and the tissues? I'm going to be asking a few questions related to math and science, math and physics specifically. I didn't figure out where you're going to sit. I should give you my seat, right? Yeah, I should. Okay.
Yeah,
I'll sit over there and ask some questions, so I'm kind of out of frame.
So this is going to be the test where you find out how much I have forgotten in 30 years.
Yes, how much you have forgotten and how much Jamal has learned. Yeah, I mean marker.
Oh yeah, for sure.
So yeah, I just got some nice, simple calculus and physics questions here. I'm gonna ask you the question, and then you're going to write it on your board, and then we'll both reveal them, and it'll be super dramatic. I got some 1-pointers, some 2-pointers, some 3-pointers, and then Final Jeopardy, where you can do a little bit of gambling, because what's a show without gambling? So let's get this first question started. A bit of a freebie, if you do ask me. Take the derivative of 3x squared plus 2x plus 1. Just looking for the derivative here. For those at home, if you don't know what a derivative is, calculus is not my thing, so I'll have someone else explain that if they want to. Okay, reveal. I didn't write the answer down, but I'm pretty sure that's right. Good stuff, 1 point all around. Told you we're going to start off with some freebies. Okay, this next question is a physics-related question. If I throw a ball into the air, what is the velocity of the ball at the peak of its flight? How fast is the ball going when it's at the peak of its flight? Okay, big reveal. 3, 2, 1. Oh, okay. No, it's not moving. Well, like at the peak, it's the zero velocity because it's gonna start coming down. Okay, well, Jamal's in the lead. Woo! You gotta root for Jamal. He's the underdog here. Sitting here with 0 degrees.
It's a testament of Mr. Johnson's education.
It is. Thank you, Mr. Johnson. Okay, on to the 2-pointers here. What is acceleration due to gravity with units? I'll take the ish answer as well. Are you good, Dad? A little more thinking. We got some more time. I'll just stare at the fish tank. It's kind of pretty.
It's a great fish tank.
Also, the fireplace is making it real warm in here. Okay, we got the reveal. The beautiful 9 point and full units meters per second squared. Beautiful. Oh, I'm surrounded by such intelligent people. Let's go. Okay. This one's a little harder. I don't know if this is a good 2-point question. Okay. So you might want to write this down as I go. Limit as x approaches 0 of sine x divided by x. Give a bit to ponder it. It's not really a solving question. It's just kind of if you know it, you know it. Should have made this a 3-pointer. This one's pretty bad. Good guess. Well, how do you rate the confidence in your guess, Dad?
Low.
Low? Dad, Jamal, what do you think? Indeterminate infinity. Unfortunately, it is 0.
Oh.
It's 1 rather. Sorry, it's 1.
Oh.
My bad. Yeah, it's kind of, you can just throw out a random guess. On to the 3-pointers, the real important questions here. Okay, assuming ideal conditions, so we're just going to get rid of air resistance because that's what we do in Physics 1. We don't need air resistance. Dad has to worry about air resistance, but we don't. Okay, assuming ideal conditions. If I shoot a cannon with a 20-degree angle, so like this, and then another cannon with a 70-degree angle, they both have the same velocity. Which one is going to hit the ground first? Which pellet that's being shot is going to hit the ground first? truth. Remember ideal conditions. Okay. Oh my god, Jamal remembers the physics exam. They hit at the same time. That's an AP physics question right there. College board is evil. They do hit at the same time. I'm not going to give the explanation because I don't remember myself, but I trust Google. Google's my homies. Okay. For the last 3-pointer. If f of x is position, what is f prime of x? I guess this really does have recency bias. It is velocity. Yeah.
Oh.
Okay. So, just the final Jeopardy here. We got the last bit. This one's a bit evil. It's a bit evil. It's a little derivative, a mechanical derivative. See if you remember your rules. Okay, write this down as I go. Find the derivative of the square root of 3x squared plus the times sine x.
Can you repeat the question?
Yeah, the square root of 3x squared times sine x. Actually, I need to do it myself. I didn't solve it. I don't want to do this. This is hard. Okay. Oh, I should use derivative calculator. That makes it easier. Sorry, I put you guys through this. Oh, the sine x is in the radical.
What? Oh, well, you didn't tell me that.
Sorry, my bad.
You didn't say that.
Oh, you both did the same thing. I feel bad.
That's evil.
That is evil. Let's see if derivative calculator agrees with me.
It's a complete guess.
It's kind of hard to guess this one actually. Oh my god, it's a nightmare. Okay, dots reveals. That might be right. I'm not sure. That one's not. Alas. Actually, I don't think it is. I'll put the answer up on the screen, right here.
Isn't the host typically supposed to get the answer before the end?
You know what? That one's on me. That one's on me. It's the first time we've done a segment, you know. Anyways. So yeah, I guess recency bias does come in. I'm taking AP Calc right now as we speak. It's ugly. The answer, it's ugly.
Wow.
Chain rule, product rule. I tried to throw it all in. That's a Mr. Johnson question right there. That could have been on the midterm. Anyways, I don't have any more things. Jamal, do you have any more questions for... this is the only time you'll be able to interact with a mechanical and manufacturing engineer.
The only time.
He's really hard to come around, you know. He's not here very often.
Okay, that's pretty daunting. So, I don't think so. No.
Okay, sounds good. Well, it's been great talking to you, Dad. Thank you for coming all the way out here once again. Do you want any to-go snacks? A muffin, maybe?
A muffin would be fabulous.
That sounds...
Because it could be such a long trip.
Yeah. back upstairs.
Back upstairs.
Back upstairs. Anyways, thank you for stopping by. It's been great having you here, Dad. Thank you. Thank you, Jamal, for playing the game and this.
Thank you so much.
Yeah.
Thank you.
See you next week.